Hello and welcome back. Today we're within the infrastructure section within Boson NetSim. I am Benjamin Williams myself, and today we're going to be configuring multi-area OSPF. I kind of took a week break on this Boson NetSim series. Went on a little vacation. I'm also a college grad student, so the work has been ramping up as we're getting closer to the end of the semester. So that's been going on. Like I said, I just took a little vacation trip out to Tennessee. Definitely still been studying my book. I got some actual real hardware switches and real actual hardware switch that I can manage through Cisco. And I also have another managed router that I got from Cisco. So we're going to be building out our lab real soon within our house itself. So I'm very excited about that. Got a lot of great content and new content coming to this channel right here. But let's go ahead and get into our configuring our multi-area OSPF. So the objective for this lab, it says configure open shortest path first OSPF for proper operation in the multi-area environment. Configure route summarization to reduce the size of the routing table and the OSPF link state database. Okay, so here's our topology. We have three routers that will be within area 1. So we have P1R3, P1R2, and P1R1. We can see that P1R1 and P1R2 are connected via a serial interface. And then P1R2 is connected up to P1R3 with an Ethernet connection. Same thing once we go to area 1. Or area 0, I apologize for that. We have P1R1 in area 0, and we have P2R1 in area 0. And then from there, we have our area 2 routers. We have 3 routers within that area, as we can see. So let's go ahead and get into our configuration. As we know, OSPF is an IGP. It will be ran within an autonomous system. All of these routers that are within the same area will share the same OSPF database. And then, like I said, all of the other areas that are not area 0 will have to connect back to area 0 because it is the backbone area. And like I said, all of the routers within the same area will share the same LSDB. They will share, they will all run the Dijkstra algorithm to find the best path to a given destination. As we know, the administrative distance for OSPF is 110. So that's enough of just spurting and spitting out information about OSPF. Let's go ahead and get into our actual configuration. So I am going to we can just keep that up there, and we can okay, we're good there. And let me duplicate this one time so I can keep the topology up on one window. Let me split this out. Put this right here. There we go. All right. So now we're going to keep our topology up here in the top left. All right. Or the top right. I'm sorry. All right. So task 1. It says configure OSPF to operate in a multi-area environment. Okay, so it says configure OSPF on P1R1, P1R2, and P1R3. Use the proper area for each interface. Refer to the topology diagram. Remember to configure OSPF to announce the loopback interfaces. If a router is an ASBR, you must configure each interface for the area that it connects with. You should use the OSPF process ID for routers as shown in the topology diagram. So let's go ahead and configure OSPF on P1R1. Let's do a conf T. Let's do a router OSPF1, and let's do a network. It looks like we have the 192.168.1.0. I can just go ahead and configure that for both this loopback interface and this serial interface. They both fall within this address range. So that'll work. So we can do the wildcard mask is 0.0.0.255 because it's a /24. And this will be for area 1. To be for area 1. Okay. We can go ahead and configure this 10.100.100.0/24 network that goes to area 0. So let's do a network of 10.100.100.0 0.0.0.255 area 0. Okay, let's do an exit. That'll be all of these interfaces on P1R1. Let's go to P1R2. Let's do an enable. Let's do a conf T. Let's do a router OSPF 1. Let's do a network. And it has 192.168.34/28, 192.168.1.17/28, and 192.168.1.49/28. So we can do all of those networks within this one statement. So we can do a 192.168.1.0, 0.0.0.255 for area. This is for area 1. Okay. And we can do an exit. And we can go over to P1R3 here. We can do an enable. Let's do a conf T. Let's do a router OSPF 1. Let's do a network of 192.168.1.0, 0.0.0.255 area 1. Exit. Okay. See if we got, okay. So we just went back to P1R1 and looks like we have 2 adjacencies, which is what we want. Looks like we have an adjacency with P1R1, and we also have an adjacency, and we can tell that by its IP address, 192.168.2.1. That is this router over here on the right side. So we have a full adjacency, which is what we want to see. And we also have a full adjacency with P1R2, which is our connection up here into area 1. So that is perfect. And we can see that is in the full state. And this is the state that we want to see within OSPF. So that is good. That means that we have the same LSDB. And we've shared routes from our OSPF database. So that everything's looking good. Let me make sure that P1R1 has its adjacency, which it does, with P1R2, which is what we want to see. This is its loopback IP address. And you can see it's full to loading, which is what we want, loading to full, I'm sorry. So that's what we want to see. And let's make sure we have our adjacencies here, which we do. So that's perfect. All right, so the next question, it says, on P1R1, display the routing table. What type of routes are in the routing table? So let's go to P1R1. Let's do a do show IP route. Okay, so we can see that we have this OSPF route, which is coming from P1R2. Okay, we can see that we have this OSPF route, which is 192.168.1.48. That is coming from, what is that coming from? That is coming from, I can look at the next hop address and figure it out, 192.168.1.34. So that's also coming from P1R2. And then we have all of these routes right here are coming from P2R1 over here, because we can see that there are inter-area routes. And what basically that means is they're in another area. So we're receiving these route advertisements from a router that's in another area, which is P2R1. We're getting all of those advertisements from it. Okay, so that's perfect. Let's go ahead and look at question number 3. It says from P1R3. So let's go to P1R3. It says ping P2R3's fast Ethernet 00's interface, which is 192.168.2.50, to ensure that you have connectivity to all the areas in the network. Okay, so let's do a do ping 192.168.2.50. Okay, and we have 5 successful pings. So we're able to ping from P1R3, which is all the way over here, and to the other area of area 2, which is P2R3. Perfect. Okay, it says on P1R1, review the database of link state advertisements. Okay, let me reread that. On P1R1, review the database of link state advertisement, LSAs, that are exchanged among routers. Okay, so let's go to P1R1. Let's do a do show IP OSPF database. Okay. And we're able to see all of the LSAs that were exchanged. So that's what the question, it says, it's review the database. So we can see our type 1 1 LSAs, our type 2 LSAs, our type 3 LSAs, which are summary LSAs. So these are all of the LSAs that are not within the same area. Well, no, I'm not. Okay, so these are the summary LSAs. These are the network LSAs, and these are the router LSAs. Okay. All right. So for question 5, it says on P1R1, display information about each device neighbor on a per interface basis. Okay. So let's do a do show IP OSPF, if I can spell OSPF, neighbor. Okay. We can see that we have the an adjacency or a neighborship with P2R1. That's its loopback 0 interface. And we also have a neighborship with P1R2, which it has a loopback IP address of 192.168.1.17. We can see that for both of these routers, we have a full adjacency with them, which means that we're sharing the same LSDB. We can see our dead timers. We can see the actual address that is configured for the OSPF adjacency. Okay. And then we can see the interface that's connected to the adjacency as well. So that's great information. It says on P1R1, display OSPF interface statistics and information. So let's do an N. Let's do a show IP OSPF. Let's give some context sensitive help. And how can we see the statistics? Maybe we just hit enter. Okay, well, I don't know. Okay, statistics and information. What's the command for this? Okay, show IP OSPF interface. Okay, show IP OSPF interface. That's what it wants. So, we can see the actual address range that's configured for OSPF right here. We can see our process ID, which is 1, our router ID, our broadcast network type. Basically what that means is that we're on an Ethernet link. If this was a serial link that was running to, we can see right here that this one changes to point. That's what I was about to point out, because it's a serial link. So from P1R1 to P1R2, we have a serial link. So that's going to be a point-to-point network type. But for P1R1 down to P2R1, we can see that's an Ethernet link. So it's going to have the broadcast network type. We can see our hello, dead timers, our wait timers. We can see the priority. So a lot of good information within this show command. Let's go ahead and move on to question 7. It says on P1R1, display general information about OSPF. So let's do a show IP OSPF. Okay, so let's look at some general information that we have. We have the process ID, which is 1. We have the router ID right there. What else can we point out in this output? We can see the areas that are configured. So we have area 0 on this router and also area 1. We can see the number of interfaces configured for area 0, which is 1, and the number of interfaces configured for area 1, which is 2. So yeah, it says that the shortest path first algorithm was executed 3 times. Down here is executed 7 times. So that's the way that we determine what our shortest path is to a given destination. So that is some great output as well. So let's go ahead and move on to task 2. It says configure OSPF route summarization. So it says on P2R1. Okay, so let's go to P2R1. P2R1. Okay. How many routes to pod 1 does this router have? So let's figure that out. Let's see how many routes do we have. So let's do a enable. Let's do a show IP IP route. That's what we want. Show IP route. So we can see that we have 4 intra-area routes, and we can confirm that by the IA that's right here, and that says inter-area OSPF route. That's what that means right there. So I just highlighted. Okay. So we can see we have 4 of these, and we're going to be doing some route summarization to basically allow all of these advertisements to just be shown as one route. And the reason that is because all of these lie within the same subnet, so we can summarize them into one actual route, so we don't have so many routes within our routing table. Because all of these addresses that are right here, if you look, they're all going to use the 10.100.100.1 next hop. That's every single one of them. So we could turn this into just a summarized route that says, hey, if you need to go to the 192.168.1.0 network, just go to 10.100.100.1. You don't have to have all of these different routes within the routing table. So we can condense that down. So let's go ahead and do that. It says on pod 1, pod 1 uses 4 continuous Class C subnets. How can you summarize the 4 subnets with a single summary route? Well, you could just do you could just summarize it into 192.168.1.0. So it says configure the summary route that you noted in the previous step on pod 1 ASBR, P1R1, and pod 2 ASBR. So it wants to do it on both of them. Okay, let's do a conf T. Let's do a router OSPF1, and let's do a context sensitive help. Okay, and we want to do route summarization. So let's do a summary address, and we can do 192.168.2.0, 0.0.0.0. Okay. So it gave the summary address. It gave the summary mask. Oh, no. So it'll be 0.0.0.255. Yep. 0.0.0. Oh, okay. So it's a regular mask. So 255.255.255.0. That's what we want. I'm giving a wildcard mask. So let's go over to P1R1 just to make sure that was correct. Let's do a show IP route. So maybe that was the wrong command. Let me do a router OSPF1, some context sensitive. So if I did configure IP address summaries. Okay, so if I did, let me go back up to the okay, so that was the wrong command. I figured that. Okay, so let me go back here and let me go here. Let me back out some. And let's do a no in front of that command because that is not right. Okay. Now we need to do an area 1 or area 0 range 192.168.2.0 255.255.255.0. Okay. Let's try that. Bless me. All right, so let's go to P1R1. Let's do a show IP route. All right, so we're able to see. Still not able to see that. Okay, let me get some help. Let's get some help on here. Oh, okay. I see what I'm. Okay, I think I see what I'm doing wrong. So it's coming from area 2. So that's the typo that we were making. Okay. So let's go back into router OSPF1, and route summarization, I understand it, but sometimes I get a little bit confused on the actual configuration of it. So sometimes I have to do a little bit of research to figure out how to implement it within different different IP protocols or different what's the word I'm looking for? Different routing protocols, basically. I get confused on how to implement it in different routing protocols like OSPF. So let's do a let's go back up. I'm trying to figure out that command that I just put in. Okay, I could do an area 0. I did range of 192.168.2.0, 255.255.255.0. This was the command that I just put in, but that's not correct. Let's go to the front of this command and put a no to negate it. Come on, NetSim. Okay. No area. Okay. So now we can do an area 2 because this network is coming from area 2. And we're doing 192.168.2.0, 255.255.255.0. Okay, maybe I did something wrong. 2, range of 192.168.2.0, 255.255.255.0. Okay. And let's do the same thing on P. Oh, okay. Yeah, I'm making a lot of mistakes on this one. So let's do a no right here. No to this command as well. Because we're on P1R1. So we need to be no. So it needs to be area 1. Okay. So yeah, area 1, range 192.168.1.0, 255.255.255.0. Perfect. All right, now let's go to P1R1 and let's do a no area 0 range 192.168.2.0, 255.255.255.0. All right, and let's do an area of 2 range of 192.168.2.0, 255.255.255.0. Perfect. All right, now let's try this. Let's do a do show IP route. Okay. So yeah, I'm still not getting the right result. Okay, so I'm not sure what I'm doing wrong. Verify that the pod 2 routes are not summarized. So yeah, they should be summarized within a single, it says it right here, /26. Oh, okay. It wants me to do the actual mask itself. I was doing 192.168.1.0, 255.255.255.0, but it wants 255.255.255.192. It wants me to break down the actual binary. Okay. So let me just do this. Let me do a do show IP protocols. Okay, I'm trying to see, is it going to show me my route summarization? It's not. So let's do a do show run. And it's going to OSPF. Let's see what we got here. Okay, so let's do a no area 1 range 192.168.1.0, 255.255.255.0. Let's do an area 1 range of 192.168.1.0, 255.255.255.192. All right. Let's do the same thing on P2R1. Let's do a no area 2 range of 192.168.2.0, 255.255.255.0. Let's do an area 2, range 192.168.2.0.255.255.255.192. Exit. Let's do a do show IP route. All right, so now we can see that it's summarized after spending about after spending about 10 minutes troubleshooting that. We finally got it. Like I said, I always get a little bit confused on how to implement summarization within OSPF or different routing protocols in general. It's a cool feature, and I understand it, but sometimes it gets a little tricky implementing it. But we've summarized this route as one single route, like I was explaining earlier, and we can see that it's going to use, no matter what, that 10.100.100.1 next hop. So we're able to summarize this route, so it's not so many routes within our routing table itself. So that's perfect. So it says on P1R1, verify that pod 2 routes are now summarized. The SBR should see the specific routes for that area 0. You should also see the summarized route for other areas. How many routes does pod 2 and pod 1 have? Okay, so let's go to P1R1. Let's do a do show IP route. All right, we're able to see that summarized route 192.168.2.0. All right, it says the SBR should see specific routes for their area in area 0. So we can see that we're getting routes from our area, which are up here, and then we're getting some routes from area 0, which is right here. And it says how many routes does pod 2 and pod 1 have? So we can see that we have 1, 2, 3, 4 OSPF routes in pod. We have 4 different routes within each pod that are being shared within OSPF. So let's go ahead and hit grade. Okay, so we did something wrong. It wanted us to do router OSPF. Oh, okay. It wanted us to do a process ID of 2. Yeah, it wants to do a process ID of 2 on this router. So that's just changing the process ID. It's probably the same thing. And it wants a process ID over here for OSPF process ID number 3. I put 1 for each router to try to keep it consistent. So let's change that on P1R2. Let's do a no router OSPF 1. Let's do a router OSPF 2. A network of 192.168.1.0 0.0.0.255 area 1. All right, and let's do the same thing on P1R3. Let's do a router. Let's do a no router OSPF F1. Okay, and let's do a router OSPF 3. Network 192.168.1.0 0.0.0.255 area 1. Exit. See if our neighbors, wait for our neighborship to come up. So now we're having detected route with duplicate router ID in area 1. So let's do a do show IP OSPF neighbor. Okay. So I think that was an error because I didn't change the, I didn't clear the IP routing table maybe. But we can see now that we just had our adjacency come up with P1R2. So let's do a grade now. And it looks like everything is correct. So thank you guys for watching this one. I'll see you in the next one.